Hi everyone, this is a video on formula writing. In Chem 20, formula writing is a huge part of the course. In all of the units, in all kinds of different scenarios, we're going to be given the name of a compound or an element, and we're going to have to come up with the formula. It's important to note that the opposite move, which we had a lot in Science 10, here's the chemical, what's the name, is not a thing that we're going to encounter. So we're going to focus on formula writing. There's three scenarios. We could have a molecular compound, an ionic compound, or an acid. If it's a molecular compound, remember that's a compound composed of nonmetals. One type of question will have prefixes as part of the name. These are mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. It really stands out because we see those prefixes right as part of the name. Here's two examples. Carbon dioxide, carbon doesn't have a prefix attached to it, which implies it's mono. So we have one carbon, we have di, which means two oxygens. Carbon dioxide, which we're all familiar with anyways. Something more involved, dinitrogen tetrasulfide. You can see nitrogen there with di, there's our two. Tetra means four, and we have sulfur sulfide, N2S4, dinitrogen tetrasulfide. The second thing that might happen for us when we encounter a molecular name is it might have a one-word name. Ethanol, ammonia, propane. These are all chemicals that have one word as part of the name. Look at the contrast. Carbon dioxide, that's two words. Dinitrogen tetrasulfide, that's also two words. But ethanol, that's just a one-word name. Depending on where you went to school, you might have been asked to memorize these chemicals in grade 10. For us, however, the data booklet is a tremendous resource. On pages 4 and 5, we have a big long table that we will end up using in grade 12. However, any chemical that we're going to encounter with a one-word name, you can just look it up. No memorizing, just look it up. The third thing that can happen, though, is for what we call diatomic elements, we do have to memorize those. So these are hydrogen, H2, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Sometimes we even say iodine. Those all receive a 2 for a subscript. Phosphorus gets a 4, phosphorus, and sulfur is S8. This is when we encounter these elements alone. Oxygen, which we're familiar with, O2, but it's the same for these other elements as well. Watch out for that P4 and S8. The second category of chemical that we might encounter is an ionic one. This is much more common for us throughout the scope of the course. Here, we're going to balance the charges. This is where we have a metal and a nonmetal, an anion and a cation. We're going to balance the charges. The total number of positives and negatives have to cancel out to give us a neutral ionic compound. Here's a couple of examples. Calcium iodide. These kinds of names always have two words, with the cation, the positive piece, always being first. We need to go to the data booklet, to the periodic table, or to the table of polyatomic ions, and look up the charge. We might end up memorizing a lot of the charges as our experience builds, but especially in the beginning, we might find ourselves having to look things up, and that's okay. If we find calcium, the data booklet tells us it's a 2 positive charge. Iodide, a 1 minus. 2 plus and a 1 minus, so we need 2 of the 1 minus charges to cancel off 1 calcium ion, which gives us CaI2. Notice that there's no prefixes ever going to be used for ionic compounds. It's all about charge. Here's a second example, sodium phosphate. We go to the data booklet, or do we just happen to remember that sodium has a 1 plus charge? Phosphate is PO4 3 minus. The data booklet tells us that. We need the total number of positives and negatives to balance off. So that takes 3 of the 3 sodiums to balance off 1 phosphate, Na3PO4. A third example is when we see one of those chemicals with a Roman numeral as part of the name. These are polyvalent cations. Don't forget that the Roman numeral is the charge. If we go to the data booklet and look up iron, we see that there's a 2 plus version and a 3 plus version specifically written right in the periodic table, but the Roman numeral 3 means we have the 3 positive version of this ion. We also go and look up sulfate. It's 2 negative. 3 plus and 2 negative, we need those to all cancel off. So it's going to take 2 irons, each of them 3 plus, makes plus 6. 3 SO4s, 3 sulfates makes minus 6, plus 6 and minus 6 cancel off. We have Fe2, SO4, 3 in brackets. We want to show that we have 3 of this thing, SO4. The final scenario for us is when we have an acid. Again, in the past, we might have memorized some specific acid naming rules. For us in Chem 20, good news, we only have to look it up. A different place in the data booklet, right at the very back, on page 8 and 9, there's a table of acids. They're not in alphabetical order, so it's not the most user-friendly table. However, if we do encounter an acid, we can always find it on that table. For example, here's sulfurous acid. I might not have any idea what that is off the top of my head, but if I take my time and look on page 8 and 9 in the data booklet, I can find the formula H2SO3. Throughout the scope of the course, we're going to be given names almost all of the time, and it's up to us to determine the formula. We have molecular compounds, ionic compounds, and acids, and we have these different ways of approaching formula writing depending on the scenario. Lots of the time we can just look things up, watch out for those prefixes, and if we have an ionic compound, it's all about balancing charge. And I hope that helps.